Welcome everyone. In this video we're going to be looking at one of the most important discoveries I found when researching Tesla's patents for the diode that he has a particular patent for a diode. I'll pop it up on the screen. I can't remember the number right now, but during the investigation of that patent I was using these toroids, which people have probably seen just lying on the bench here in some of my other videos. I think I've mentioned them before. I wanted to get back to them. It's pretty important because it's what is responsible for running a light like that. It's partially responsible, but an essential component. My circuit is what gives it its ability to be part of an essential component. That's what I asked about. But anyway, using these toroids, I was doing that because in Tesla's patent for the diode, it uses transformers and winding coils in particular directions, and putting two of these coils together. And it was during those experiments that I noticed the 0 watt effect there, 0 amps and 0 watts, and that is purely because of the toroid. So we can see here on the meter, so we come from the power supply through this meter, and I'll just show you that it is working, and we will short out these LEDs here. I gotta watch what I'm doing in the real world so I can get it right. Okay, so we pop on those LEDs and we can see in that direction, and by that I mean with the LEDs facing in the direction they're facing, or positive on this side and negative on this side, whichever it is, it will use obviously 0 watts in that manner. But if I am to flip that around, take that off there, and we will flip that around and place that on there, and then we can see that it does indeed draw power. But if we flip it the other way around, get that on there first, and then we can see we're back to the 0.0 watts. Now that won't normally happen in a circuit. It requires my circuit there to allow that to occur. So it's important that you understand, and most of the videos leading up to this point are sort of walking everyone towards this point. But with that understanding of how we get there. So I don't know how much longer I can do this. My government seems to be hell-bent on silencing the truth, so I'm going to put this out there now. You guys can decide what it becomes. The schematic, like always, will be at the end. 90% of what you see here is experimental. And you know, practically to achieve this, none of all of that is required. When you've got a circuit that is not actually consuming anything, and if I turn that off and reset that meter, we can see that there's no current draw and no accumulation. So when I leave it on for a really long time, like a couple of days, over this side you should see if there was any power, even a tiny bit, this would show up on the amp hour and watt hours of consumed power. So it'll work on the SLA, the sealed lead acid batteries. It'll work on, old car batteries. I just picked up these new lithium batteries. No real difference, to be honest. The point here is that the circuit isn't actually consuming anything, and I know, there'll be those who this will be breaking your little brains right now. I don't mean that in an offensive sense, but just I understand. I've been there. I've dealt with the struggles. This isn't my work, so just before you decide to attack me, I'm just showing you what Tesla. This is what I discovered when studying Tesla's work. Now, because it sort of joins into that magnetic and electric relationship. I've got two magnets here, and we can see, like, if the magnets are in attraction mode to each other, then there's no variation on the light or the wattage consumption. However, if I'm to flip that magnet over, and now we can start to see the light, first of all, like I'll move that closer, and you'll see fluctuation there on the light and on the meter as well when it gets close enough. So but why would this be important? Like, if you want to run, say, another light, so I've got this light over here, which is a 240 volt. I can't run that one for long because that's going to burn the table. 240 volt, and that is influenced by the magnets. As the magnet goes on, I'll see if I can. I couldn't really, because I'm experimenting with this all the time. All of this stuff, in my opinion, is necessary for me to discover all these things. But keep in mind that with this circuit not consuming power in the state that it's in, you don't need to feed back to the battery. I mean, there's just no point. So I'm feeding a second battery there. There's no point, because it doesn't. It feeds itself off of the principles that Don Smith would talk about. So we've got to see here, like, if you're using this magnet arrangement, you can get a nice well lit light there, but that uses power. And so if I take that magnet off, here we get a dimming of the light, but we're back to this. Now, if I short out, I know it's this. I mean, initially I did tests with potentiometers to resist the current into the circuit to achieve that feature. And I'll turn that off so that resets that meter back to zero from when I was just using the magnet, because the main benefit of this circuit is having it draw no current, so it actually just operates off of the potential. It just needs that potential voltage in the battery, and then because of this feeding back pulse DC along these power lines, and the power line itself coming from the battery is resonant in length, so it's a resonant length of wire to what is on the coil there, and that allows it to be fed wirelessly like a radio wave. So it recharges off of its own wires. If you don't understand how that works, go and check out on my channel. I've got several videos about it. But guys, that's the big secret. So let's bypass that. This is the way my circuit would run without that. We'll go on there, and you can see straight away brighter, right? But 5.9 watts. That light is nice and bright also, and that's running through earth, so that green wire there comes down inside. It is powered by my main coil. Again, the tutorials on my channel there. So that is powered through earth. Over one wire is 60 meters in length, and the two earth rods are 60 meters apart. I think the other wire is about 10 meters in length. That's not really too important. The main thing is here is to get the resistance correct. So your circuit may be a tiny bit different, so that's where you start off with potentiometer, find out that correct value, and then replicate that in wire, just using a wire length. And if we connect that back on there, okay, we get our light back on. Now again, not as bright as it was before. All right, like clearly it's a lot dimmer, but what we're talking about here is a light that runs for free. All right, so I just leave it there, and days go by, and then still no power use. The battery's still at the same voltage. You'll get the natural depletion if you're not feeding back to a source. Sometimes you can get a natural degradation of the potential voltage, but it's tiny. It'll be like 0.01. So yeah, it's just something to think about. It's maybe not as hard to do this sort of stuff as we were educated, and it's not that those who work these things out are not so much that they've done something special. It's just that well, in my case, all I did was read Tesla's patents in relation to the magnetic diode, again, which I'll put on the screen and put in the description down below. That's all it is, and it seems explained so easily in Tesla's patents, as well as with the pictures there, the diagrams. It's just pretty damn obvious, and you think to yourself, surely it can't be so easy. But you throw a few wires together, and now I have done tests here with how the different resistance of wires and that sort of stuff. And so, again, you can power up this side, and so there we've got, that's the wrong way to put the diodes, because that is now opposing the magnetic flux that's running through that. That's a ring, and because the coil is wound in a direction, and so now we've got a motion. And so if we place these LEDs this way, it's dim but consumes no power. Now that's because of my circuit doing that. It places that pulse DC on the power lines, places it everywhere inside the circuit actually. So you can see that with a neon up close. And I know it's DC because this AC meter never is triggered by placing it anywhere in the circuit. So yeah, I know it's pulse DC. So I just found it interesting that you can get that effect with the magnets. Flip that magnet over, and I've just disconnected the power supply there. So if we put that back, and yeah, just by moving the magnet away from the other magnet, so the toroid is actually sandwiched between the magnets, and you can get that high voltage. That's a 220 volt. I think it's about a 4 watt LED bulb. I have no idea what that tiny bulb's for. If I take that away, we can see it. But yeah, that takes 240 volt to or 220 to 240 to light that up. Probably takes less, but that's what it's rated like to go into the mains electricity. So again, magnet on that side uses power, magnet on the other way, so they're both facing in, uses no power. So yeah, interesting stuff. Thanks for watching. Hope this helps. Gobble up the information as quick as you can, because I don't know how much longer I can do this with the government going full authoritarian and placing the requirements for an ID to go online. I'll tell you now, that'll take people like me offline. So get it all while stocks last. Thanks for watching. Have a nice day.